In the quiet aftermath of the First World War, as Europe struggled to rebuild its cities and its soul, a new kind of war was brewing, one not of armies or borders, but of ideas. It was fought not on battlefields, but in laboratories, lecture halls, and in the restless minds of two men who had come to symbolize the most profound intellectual struggle of the 20th century. On one side stood Albert Einstein, the patriarch of relativity, the man who had bent time and space into a single fabric of cosmic unity. On the other stood Werner Heisenberg, a brilliant young physicist from Germany whose mind moved with the speed of light and whose equations would tear at the very foundations of certainty itself. Between them stretched a single haunting question: what is reality? Einstein had grown up in the classical world, a universe built by Newton and refined by Maxwell, where every cause had its effect, every motion its predictable consequence. It was a clockwork cosmos, vast yet comprehensible, operating by precise laws that the human mind could, in principle, uncover. For Einstein, physics was not merely about describing observations, it was about revealing the hidden architecture beneath them. His relativity theory had already shattered the old assumptions about time and space, but even that revolutionary vision rested on the belief that reality existed independently of the observer. The moon was there whether or not anyone looked at it. Truth was objective, not dependent on human perception. Heisenberg's world, however, was born in the uncertainty of the atomic age. When he peered into the heart of matter, the laws of certainty dissolved. Electrons did not behave like planets orbiting a sun. They flickered between possibilities, sometimes waves, sometimes particles, never both at once. In 1925, while isolated on the small island of Helgoland to recover from hay fever, Heisenberg conceived a radical new way to describe atomic behavior: matrix mechanics. It dispensed with the comforting images of orbits and trajectories, replacing them with arrays of numbers that predicted only the probabilities of where a particle might be found. The universe, it seemed, was not a clock but a symphony of chance. This was an idea that struck Einstein like lightning, but not in admiration. To him, physics had always been a sacred pursuit of clarity. To see the laws of nature reduced to probabilities was to admit defeat before the mystery of existence. Heisenberg's uncertainty principle, formulated in 1927, declared that it was impossible to know both the position and momentum of a particle simultaneously with infinite precision. The more precisely one was known, the less certain the other became. This was not a limitation of technology, but of nature itself. In those words, Einstein heard a betrayal of centuries of scientific faith. God does not play dice, he would later declare, dismissing the notion that the universe might be governed by chance. To understand why this disagreement cut so deep, one must return to the essence of classical thought. For 300 years, physics had been the story of order emerging from chaos. The success of Newton's laws and later Maxwell's equations of electromagnetism had convinced scientists that everything in nature could be predicted. If only one had enough information, the position and velocity of every particle could, in theory, determine the entire future and past of the universe. Einstein inherited that faith and refined it through the geometry of space-time. His equations showed that matter and energy shaped the curvature of reality itself, and yet, for all their complexity, they were deterministic. Nothing in relativity was left to chance. To Einstein, this was the beauty of the cosmos: lawful, elegant, inevitable. Heisenberg entered this story as a disruptor. His quantum mechanics was born not from philosophical rebellion, but from sheer necessity. When classical physics failed to explain the behavior of atoms, when electrons refused to follow predictable paths, Heisenberg found refuge in abstraction. By ignoring what could not be observed and focusing only on measurable quantities, like spectral lines and energy transitions, he created a theory that worked astonishingly well. It predicted the hydrogen atom's energy levels with mathematical perfection, yet it also destroyed the notion that particles had definite properties until they were measured. Observation was no longer passive; it shaped reality itself. Einstein could not accept that, to him, the act of measurement should reveal a property, not create it. Physics, he believed, should describe the world as it exists, not as it appears under observation. If Heisenberg was right, then reality was not merely unknown before observation, It was undefined. This was not science as Einstein understood it. This was philosophy teetering on the edge of mysticism. He respected Heisenberg's brilliance but regarded his uncertainty principle as an admission of failure. A great mind, he thought, does not celebrate the limits of knowledge. It overcomes them. But Heisenberg saw the matter differently. In his view, Einstein was clinging to a dream of certainty that no longer belonged to the modern world. The experiments were clear. Electrons diffracted like waves, photons interfered with themselves. Particles existed in superpositions of states. The quantum realm did not obey the tidy laws of determinism. To impose classical logic upon it was like trying to map the ocean with a ruler. Heisenberg's insight was not that the universe was chaotic, but that it was fundamentally relational. What could be known depended on how it was observed. Nature did not reveal her secrets all at once. She offered them in complementary fragments, each one illuminating a different aspect of reality. Their differences crystallized into one of the most famous intellectual duels in history. In the late 1920s and 1930s, during the Solvay conferences in Brussels, the world's greatest physicists gathered to debate the meaning of quantum mechanics. Einstein would arrive with his notes full of thought experiments designed to expose the inconsistencies in Heisenberg's theory. Heisenberg, often accompanied by Niels Bohr, would defend the new physics with fervor and calm precision. The air in those rooms was electric. Bohr, the philosopher king of the quantum revolution, often mediated between them, but Einstein's skepticism never softened. He would rise from his chair, pacing, gesturing, his deep voice challenging the logic of indeterminacy. Heisenberg would respond with mathematical elegance, explaining how every experiment confirmed the principle. To the young quantum pioneers, Einstein was both revered and frustrating, an old lion roaring against the dawn. The conflict was not merely scientific, it was generational. Einstein's relativity had once been considered radical, yet now he found himself cast as the defender of realism against a new wave of abstraction. Heisenberg, barely 30, was the voice of a future that defied intuition. Their debates were not clashes of arrogance but of integrity. Each man saw himself as a guardian of truth, and both were right. Within their own frameworks, Einstein's logic demanded a universe of hidden order, one where randomness was only a reflection of ignorance. Heisenberg's mathematics demanded humility, for it showed that even the most fundamental quantities could not be pinned down. Between them stretched the very definition of what it means to know. The emotional current running beneath their intellectual struggle was profound. Einstein admired Heisenberg's genius, but pitied his philosophy. Heisenberg adored Einstein, but saw in him the shadow of a fading era. In private letters and public debates, their words revealed not hostility but a tragic tension between two visions of beauty. Einstein once told Heisenberg that while his mathematics might be correct, it could not be the final truth, because it left too much to chance. Heisenberg replied that the universe did not owe us determinism, it owed us understanding. That understanding, he argued, had evolved. Nature's secrets were subtler than human expectations. As the 1930s unfolded, the implications of the uncertainty principle began to reshape science and philosophy alike. The old dream of a fully predictable cosmos gave way to a world of probabilities and wave functions, where outcomes could only be described statistically. This shift was not easy for the human mind to accept. For centuries, science had been humanity's rebellion against fate. Now it seemed to suggest that fate itself might be probabilistic. In the laboratories of Copenhagen, Göttingen, and Berlin, Heisenberg's equations found experimental confirmation again and again, yet Einstein continued to resist, not out of stubbornness, but out of conviction that something essential was missing, a deeper theory that would restore causality. In this way, the clash between Heisenberg and Einstein became a mirror of the human condition. It reflected the eternal tension between the known and the unknowable, between control and surrender. The deterministic world offered comfort, a belief that with enough data, everything could be predicted. The quantum world demanded faith in uncertainty, an acceptance that some truths could only be glimpsed through probabilities. For Einstein, this was intolerable. For Heisenberg, it was liberation. The two men embodied not just competing theories but competing temperaments. Einstein's mind sought unity, Heisenberg's embraced paradox. Their confrontation was not resolved, for it could not be. It was the kind of argument that defines an age, not ends it, and in the quiet corridors of physics departments around the world, their voices still echo, one insisting that the universe is knowable, the other whispering that mystery is its essence. The battle between certainty and uncertainty, between realism and probability, was not just about atoms or waves, it was about the very nature of truth. Einstein's universe was one of elegant inevitability, Heisenberg's, one of shimmering potential. Between them lay the great question that science still wrestles with: does reality exist independently of us, or are we woven into its fabric, shaping it with every act of observation? As the years passed, history would vindicate neither man entirely. Quantum mechanics would triumph as a practical tool, predicting phenomena with astonishing accuracy, yet Einstein's doubts would linger, inspiring generations to search for hidden variables, for deeper layers beneath the quantum fog. Even today, as physicists explore quantum entanglement, decoherence, and the fabric of space-time, the ghost of their debate haunts every discovery. The first keynote, the clash between classical certainty and quantum uncertainty, was not just a scientific moment, it was the beginning of a new way of seeing existence itself. The night skies of the early 20th century were filled with quiet wonder, but beneath their stillness the human understanding of the universe was coming apart and being rebuilt. Einstein, the elder statesman of physics, had once been the symbol of that reconstruction. His equations had unified gravity and geometry, showing that time itself bends under the weight of matter. But in the shadows of the atom, a new revolution was brewing, one that seemed to mock the very certainty he had restored. Heisenberg, with his calm gaze and sharp mathematical intuition, was at the heart of it. To him, uncertainty was not chaos, it was the hidden rhythm of creation. Every flicker of an electron, every collapse of a wave function, was a whisper from a universe far more alive and spontaneous than human logic could tolerate. As the Solve debates grew more intense, Einstein would often challenge Heisenberg and Bohr with his favorite weapon, the thought experiment. These were not casual mental games. They were surgical strikes of reason. He would describe scenarios in which particles, mirrors, or clocks seemed to expose contradictions in quantum theory. Each example was meant to reveal that if uncertainty were fundamental, then the laws of conservation or causality would eventually fail. Bohr, ever the philosopher, would pace the room and reply with counter-arguments that redefined the very meaning of measurement. Heisenberg, younger and quieter, would observe, taking in the intellectual storm that swirled around his ideas. It was said that sometimes Einstein would smile, satisfied that he had found a flaw, only for Bohr to return the next morning, sleepless but triumphant, having unraveled the paradox and preserved the new physics once more. To those who watched, these encounters were like witnessing two gods arguing over the design of the cosmos. Neither man shouted, neither disrespected the other. Theirs was a duel of intellects, so refined that even disagreement felt like art. Yet beneath the civility, there was a growing tension, a recognition that they were not simply defending equations, but opposing conceptions of existence. Einstein's mind sought an underlying order, a deeper layer where the randomness of quantum events would dissolve into a more perfect logic. Heisenberg, on the other hand, saw in that randomness the final truth. The uncertainty principle, he believed, was not a flaw in knowledge but the very fingerprint of reality itself. It told humanity that the universe was not a mechanism wound at the beginning of time, but a living process of probabilities constantly unfolding in the act of observation. As years passed, the divide between them became both scientific and emotional. Einstein's faith in determinism was not arrogance. It was rooted in awe. To him, the divine was expressed in the harmony of mathematical laws, and any suggestion that the universe operated by chance was almost sacrilegious. Heisenberg's faith was of another kind. He believed that humility before mystery was the highest form of reverence. His equations were not merely predictions but confessions, that human beings, no matter how brilliant, could never stand outside the universe and observe it in totality. Every measurement was participation. Every act of knowing was an act of creation. For Einstein, this sounded too poetic, too subjective. He feared that physics was drifting away from its anchor in objectivity. In letters exchanged over the years, one can feel the deep, almost father and son tension between them. Einstein wrote with gentle skepticism, urging Heisenberg to search for a hidden reality beneath the probabilities. Heisenberg replied with respect but firmness, insisting that nature itself refused to be boxed into deterministic rules. Their correspondence reveals admiration entwined with sadness, the recognition that they shared the same passion for truth, but walked different paths toward it. Einstein once told a colleague that he felt like an old man watching the young dismantle the cathedral he had built, brick by brick, replacing it with a house of mirrors. Heisenberg replied that those mirrors reflected the universe as it truly was, not as one wished it to be. The world around them was changing too. The 1930s brought political darkness across Europe, while ideas of relativity and quantum mechanics reshaped science. The rise of totalitarianism reshaped civilization. Heisenberg remained in Germany, caught between loyalty to his homeland and the horror of its descent into dictatorship. Einstein, a pacifist and a Jew, fled to America, his heart heavy but his mind still restless. Though the Atlantic now separated them, the debate never truly ended. Einstein continued to search for a unified field theory that would reconcile all forces of nature into a single mathematical structure. Heisenberg continued to explore the depths of the quantum world, convinced that uncertainty was a universal law, that even the cosmos itself could not escape. When the atomic bomb brought the quantum age into terrible reality, the moral weight of their discoveries became undeniable. Heisenberg, haunted by his wartime research, retreated into philosophy, pondering the limits of human responsibility in science. Einstein, too, grieved that his equations of energy and mass had been used to unleash destruction. In those years of reflection, both men looked inward. Einstein still wrote that the quantum world was incomplete, that there must exist hidden variables restoring causality. Heisenberg, though burdened by history, stood by his principle. The universe, he said, was not a book already written, but a story being told as it happens. Probability was not ignorance, it was the pulse of creation itself. Their battle, though waged through equations and conferences, was profoundly human. It was about fear and wonder, control and surrender. Einstein's mind yearned for certainty because certainty meant understanding, and understanding meant peace. Heisenberg's acceptance of uncertainty was not surrender but courage. The courage to admit that knowledge has boundaries, that even the brightest minds must sometimes bow to the unknown. This difference reflected two philosophies that would echo through every scientific generation after them. To seek the hidden variables was to believe that reality was objective and complete. To embrace uncertainty was to accept that the observer and the observed are inseparable. When they met again in later years, their discussions had softened but not changed. Einstein, older and slower, would still raise his eyebrow and say, "Do you really believe the moon isn't there if no one looks at it?" Heisenberg would smile gently, as if to say that the moon itself might not care. By then, the younger man had seen the quantum revolution reshape chemistry, electronics, and the very foundations of modern technology. The transistor, the laser, the computer, all bore the signature of the uncertainty principle. The world was running on the mathematics Einstein had doubted, and yet, in an irony only history could craft, even Heisenberg's theories seemed to validate Einstein's dream. Quantum mechanics, though probabilistic, still operated within laws of symmetry and conservation, elegant in their own right. The dice God appeared to throw were, perhaps, loaded after all. Their intellectual war became a legend, not because one defeated the other, but because both revealed different faces of truth. Einstein taught humanity that the universe possesses structure, coherence, and beauty that can be captured through reason. Heisenberg showed that within that beauty lies an irreducible mystery, that precision has a price, that knowing comes with disturbance. Together they gave science a soul. Without Einstein, physics would lose its elegance. Without Heisenberg, it would lose its humility. The tension between their visions became the heartbeat of modern thought, inspiring not only physicists but philosophers, artists, and theologians to question what it means to perceive reality, Today, their dialogue continues in new forms. Quantum computers operate by embracing uncertainty. Cosmologists study quantum fluctuations that may have seeded the galaxies. The entanglement that Einstein once mocked as spooky action at a distance is now a verified phenomenon that challenges every classical intuition. Yet the questions remain the same. Is the universe fundamentally probabilistic, or is there a hidden order waiting to be uncovered? Is reality something that exists independently of us, or is it a participatory dance between the cosmos and consciousness? In every laboratory, in every experiment that probes the limits of the observable, Heisenberg and Einstein still argue in silence. Looking back, the first keynote, the clash between classical certainty and quantum uncertainty, emerges not merely as a scientific debate, but as a portrait of the human spirit. It captures the struggle between the comfort of clarity and the awe of ambiguity. Einstein's defiance reminds us to seek unity even when the world seems fragmented. Heisenberg's surrender to uncertainty reminds us that not all fragmentation is chaos. Sometimes it is the texture of creation itself. Their conflict teaches that progress in understanding does not come from agreement, but from tension, from the friction between opposing insights that sparks new light. If one listens closely to the echoes of their arguments, one hears not contradiction but complementarity. Einstein's demand for realism keeps science grounded. Heisenberg's embrace of indeterminacy keeps it open. One without the other would render physics either blind or paralyzed. Together they carved a space where knowledge and mystery coexist. In that sense, their battle was never about victory. It was about balance. Einstein wanted to know how God thinks. Heisenberg wanted to understand how thought itself changes what it observes. The truth, perhaps, lies somewhere in between. As the century turned and new generations of scientists looked back on the giants who had built the quantum world, they realized that the argument between Heisenberg and Einstein had transformed from a dispute into a dialogue that transcended both. It was no longer about who was right, but about how both were necessary. In the dance of atoms and galaxies, there is room for both order and uncertainty, both law and freedom. The first keynote, the battle between classical and quantum visions, remains a timeless lesson, that the search for truth is not a straight line but a wave, oscillating between what we can know and what we must simply wonder at. Their lives ended, but their ideas never did. Einstein died in 1955, still chasing the unified field that would make sense of everything. Heisenberg lived 2 more decades, teaching, writing, reflecting, never losing the calm conviction that the quantum world was not disorder, but design of another kind. The correspondence between them, the debates at Solvay, the equations scribbled in chalk, all became the scripture of modern physics, and though their conclusions diverged, their purpose was one: to touch the infinite through understanding. The battle for the nature of reality was never truly between Einstein and Heisenberg. It was between humanity's longing for certainty and the universe's whisper that certainty may be an illusion. The more we study their legacies, the clearer it becomes that both men, in their opposing visions, carried fragments of a deeper unity. Einstein's equations described the large, the cosmic, the smooth curvature of spacetime. Heisenberg's mathematics describes the small, the trembling quantum fabric that underlies everything. Between these two scales lies the world we live in, where certainty and uncertainty merge. The bridge between them has yet to be built, and perhaps that is how it should be, for in that gap, between what we know and what we cannot, is where wonder resides, and where science draws its eternal breath. And so the story of their battle closes not with victory, but with harmony. A harmony uneasy yet beautiful, like the resonance of 2 strings vibrating in tension. Einstein's belief that reality is objective and eternal continues to guide our search for cosmic laws. Heisenberg's insistence that reality is relational and elusive reminds us to approach those laws with humility. Their argument lives on in every experiment, every theory, every question that begins with why. For in questioning, as they both knew, lies the truest form of reverence. The battle for the nature of reality was not won or lost. It became the heartbeat of modern thought, echoing across time, reminding us that to seek truth is to stand forever between certainty and mystery, and to find beauty in both. the roots of Einstein's belief in a deterministic universe stretched far deeper than mere scientific preference. They reached into the very philosophy that had shaped his soul. He was not a man who simply calculated, he was a man who contemplated. To him, physics was the language of God, written in the hieroglyphs of mathematics, and to misread it was to misinterpret the mind of the Creator. In his youth, Einstein had fallen in love with the clarity of classical mechanics, the precision of Newton's laws, the harmony of Maxwell's fields, the elegance of geometry. All of it spoke to a cosmos that was not chaotic but profoundly ordered. He once said that the most incomprehensible thing about the universe is that it is comprehensible. That statement revealed his creed. Behind every motion, behind every flicker of energy, there lay a reason, a pattern, a purpose waiting to be uncovered. This conviction guided everything he did. When Einstein derived the special theory of relativity, he was not breaking the order of the universe, but revealing a deeper layer of its symmetry. He had shown that time and space were not separate fabrics, but threads woven together by the speed of light. In doing so, he reaffirmed the unity of nature, an idea that thrilled his mind and calmed his spirit. For him, science was not a battlefield of uncertainty, but a cathedral of reason. To question its determinism was to invite chaos into a structure built upon centuries of intellectual discipline. The notion that nature could operate through probability alone was to him as unthinkable as a clock that kept perfect time by accident. The arrival of quantum mechanics therefore struck Einstein not as revelation but as rebellion. He admired its ingenuity, yet he distrusted its implications. When Heisenberg, Schrödinger, and Bohr began to describe a world where particles existed in clouds of possibility, where observation itself defined outcome, Einstein saw a dangerous shift from realism to abstraction. The old physicist feared that the new generation was mistaking mathematical convenience for truth. Equations, he believed, must describe what is, not what might be. The universe did not dice with chance, it operated with necessity. Every event, every fluctuation, every twist of an atom was, in his view, the inevitable result of prior causes. Even when we could not see those causes, they were there, hidden beneath the surface like the unseen gears of a great cosmic mechanism. To Einstein, determinism was not merely a principle of science, it was a moral compass for thought. It reflected the belief that the universe was intelligible, and that humanity's task was to decode it, not to surrender to randomness. He feared that by accepting quantum uncertainty, physicists were abandoning the dream of complete understanding. If probability ruled the microcosm, then the very foundation of knowledge was compromised. How could one claim to know anything about nature if nature itself refused to be definite? His debates with Bohr and Heisenberg were not about equations, they were about the soul of science. Einstein wanted physics to remain a mirror of objective truth, not a reflection of human perception. He wanted the cosmos to exist independently of the observer, with or without the gaze of consciousness. When he famously said, "God does not play dice with the universe," it was not a dismissal of religion, but an expression of faith and rationality. To him, God was not a magician, but a mathematician. The divine was expressed not in miracles, but in laws, immutable, elegant, eternal. Randomness was an insult to that divinity. He did not mean that every human event was predestined. He meant that the universe, as a total system, unfolded according to reason. For Einstein, physics was the closest humanity could come to reading the mind of God, and the mind of God, he believed, was lawful, not whimsical. The beauty of a deterministic universe lay in its coherence, every part affecting every other, every equation echoing a hidden symmetry. It was this coherence that made relativity so profound. When Einstein showed that gravity was not a force but the curvature of space-time caused by mass, he revealed a universe in which geometry and matter were intertwined. Objects moved along the fabric of space-time not by choice, but by necessity. Even the bending of starlight during an eclipse was predictable, measurable, inevitable. There was no randomness in such a cosmos. There was structure and inevitability. Heisenberg's uncertainty principle, by contrast, seemed to undermine that order. If one could not know both the position and momentum of a particle simultaneously, then how could one speak of cause and effect? If observation altered reality, then what was reality when no one observed it? To Einstein, such questions bordered on metaphysics, not physics. The irony was that Einstein's own theories had once been accused of violating intuition, when he proposed that time dilates and lengths contract, that simultaneity depends on the observer. Many physicists called it madness, yet Einstein had insisted that his ideas were grounded in reason, not subjectivity. The observer in relativity did not create events, he merely measured them from a different perspective. Reality remained objective, only its description changed with motion. But in quantum mechanics, Heisenberg and Bohr were suggesting something far more radical, that the act of measurement did not merely reveal, but determined, the state of a system. This was a bridge too far. For Einstein, it was as if science were no longer describing the universe, it was inventing it. The deeper the quantum theory spread, the more isolated Einstein felt within the community he had helped inspire. The young physicists spoke of wave functions collapsing, of probabilities governing existence. They used phrases like the observer effect and complementarity, words that sounded to Einstein more like philosophy than physics. He respected their success. The predictions of quantum mechanics were extraordinarily accurate, but accuracy did not equal truth. A map might lead one to the right destination and still fail to depict the true landscape. Einstein believed that beneath the randomness of the quantum world lay a hidden order, a layer of reality yet undiscovered. He called this hidden variables, and he spent the rest of his life searching for them, convinced that the apparent chaos of particles concealed a deeper determinism. This belief made him a kind of prophet in exile. While the rest of physics moved forward into the probabilistic age, Einstein kept looking backward toward a world governed by causality. He was not nostalgic, he was steadfast. He once said that he could not believe that the same God who created the harmony of the heavens would abandon order in the atom. His search for unity became a spiritual journey disguised as mathematics. Even in his old age, he filled notebooks with equations attempting to merge electromagnetism and gravity, hoping that such a unified field would reveal the hidden structure of all phenomena. He failed to find it, but in that failure lay a strange victory. He refused to accept the comfort of ignorance. His doubt was a form of faith, yet the younger generation was not blind to his reasoning. Heisenberg admired Einstein deeply, and in moments of honesty, even he confessed that Einstein's longing for certainty had a moral grandeur. To live in a world where everything was probabilistic required a different kind of courage, the courage to dwell in ambiguity. Einstein's courage was of another kind, the courage to insist that reason must ultimately triumph. In this difference lay the beauty of their opposition. Heisenberg's uncertainty principle was like the music of the cosmos, fluid, unpredictable, ever-changing. Einstein's determinism was like its architecture, solid, eternal, geometric. The two were not enemies but different expressions of the same truth. Einstein's belief in determinism extended even into his personal life. He often spoke of destiny as though it were written into the fabric of space-time itself. In letters to friends, he would say that the distinction between past, present, and future was only an illusion. However persistent, that statement, born from his relativity equations, reflected a view of the universe as a four-dimensional whole, where time does not flow but simply is. Every event that has ever happened or will ever happen already exists, laid out across the continuum like pages in a cosmic book. To him, free will and chance were illusions born of limited perspective. We move through time, but time itself does not move. Everything that will occur is as real as what has already occurred. Such a vision of determinism is awe-inspiring and terrifying at once, a universe of perfect order where even the flutter of a photon is already written. Heisenberg, hearing such ideas, could only smile. He agreed that the universe was mathematical but not frozen. To him, it was alive, unfolding, unpredictable. The future was not written. It was woven. Einstein's equations described the stage, but Heisenberg's captured the improvisation that took place upon it. Yet for Einstein, this improvisation was unthinkable. He believed that if one could know all the initial conditions of the universe, the position and velocity of every particle, then one could predict the entire future. The universe was a grand equation awaiting solution. Even when quantum mechanics challenged that dream, he refused to let it go. He called quantum randomness incomplete, an artifact of ignorance, not an inherent feature of reality. For him, science could never rest until it restored certainty to the heart of matter. Einstein's faith in determinism was also a protest against the idea that human perception could define existence. He saw in that notion a subtle arrogance. The universe, he believed, does not need witnesses to be real. It existed long before consciousness arose and will continue long after it fades. The moon shines, the stars burn, the particles spin, all whether or not eyes behold them. To suggest otherwise was to make humanity the center of creation again, repeating the ancient error that Copernicus had overturned. He wanted science to remain humble before the vastness of nature, not self-centered around the act of observation. That humility to him was the essence of realism. In his final years, Einstein would often sit at his desk in Princeton, staring at equations, surrounded by books, pipe smoke curling in the quiet. Visitors described an old man whose eyes still burned with the same youthful fire that had once bent starlight. He spoke less of relativity and more of unity, less of the external world and more of the eternal. His belief in determinism had become a philosophy of life. He saw the universe as one infinite whole, unbroken and complete, where every event, from the birth of galaxies to the fall of a leaf, followed the same unyielding laws. To live within that order was, for him, to glimpse eternity. To deny it was to accept chaos. The irony is that while Einstein's determinism was rooted in reason, it carried the tone of faith. It was the faith that truth is not subjective, that meaning is not a human invention, that behind the curtain of appearances lies something absolute. It was a belief that science, when pursued with honesty, brings us closer not only to understanding but to reverence. Heisenberg's uncertainty may have described the mechanics of particles, but Einstein's determinism described the yearning of the human spirit for structure, for purpose, for cosmic belonging, and in that yearning he became something larger than a scientist. He became the last great philosopher of order in an age that had fallen in love with uncertainty. The twilight of Einstein's career was a paradox in itself. He had become both the symbol of modernity and the last guardian of an older faith in order. The same man who had shattered the classical universe now stood as its defender against the wave of uncertainty unleashed by Heisenberg and his generation. Yet there was no bitterness in him, only a kind of quiet sadness that truth had become slippery. He once told a colleague that the new physics worked beautifully but said nothing of reality. For him, reality was not a collection of probabilities, it was the totality of what is. A theory that left existence dependent on observation was, in his words, a physics of dreams. He wanted to awaken the field from what he saw as a self-imposed illusion. In those later Princeton years, Einstein would return again and again to a simple thought experiment. What would it mean if one could know everything about a system? Imagine, he said, that we had a perfect mind, capable of holding the position and momentum of every atom in the universe. Then the future and the past would lie open before us, as inevitable as the pages of a completed novel. This vision was the purest form of determinism. It assumed that randomness was merely the shadow cast by ignorance. If the observer were omniscient, the dice would stop rolling, and all the chaos of quantum mechanics would collapse into perfect order. It was not that Einstein denied the statistical success of Heisenberg's theory, he denied that statistics were the ultimate truth. To him, probability was a human crutch, a way of coping with incomplete information. Nature itself, he believed, needed no such crutch. Heisenberg, when he heard such reasoning, felt both awe and discomfort. Awe because he recognized in Einstein's insistence the grandeur of classical thought, the vision of a cosmos bound together by logic. Discomfort because every experiment whispered otherwise. When electrons interfered with themselves in the double-slit experiment, when photons seemed to choose paths only when observed, it was as if the universe itself resisted Einstein's longing for clarity. To Heisenberg, the uncertainty principle was not a statement of ignorance but a law of being. It was not that we lacked knowledge, it was that knowledge itself had limits. The world, at its deepest level, was relational, not absolute. For Einstein, This was intolerable. For Heisenberg, it was revelation in the mid-1930s. Einstein tried to demonstrate the incompleteness of quantum mechanics through what became known as the EPR paradox, written with Podolsky and Rosen. They imagined two particles once connected and then separated by great distances. If measuring one instantly determined the state of the other, then information seemed to travel faster than light, an impossibility according to relativity. Therefore, they argued, quantum mechanics must be missing hidden variables that restored causality without such spooky action at a distance. Heisenberg and Bohr replied that Einstein was still thinking too classically. The particles were not two separate objects, but part of a single, entangled system. Measuring one was not sending information to the other, it was revealing a property of a whole. Reality, they insisted, was not localized but holistic. What Einstein saw as spooky, they saw as profound. This disagreement revealed how differently the two men viewed the same cosmos. Einstein saw parts interacting through laws. Heisenberg saw wholes revealing themselves through measurement. Einstein sought the ultimate equation. Heisenberg accepted the ultimate paradox. Their exchange became a philosophical mirror reflecting the duality of human thought, the rational and the intuitive, the architect and the poet. Einstein's world was timeless geometry. Heisenberg's was dynamic probability. One demanded perfection, the other celebrated possibility. And yet, through their opposition, science advanced. Every challenge from Einstein sharpened the quantum theory, forcing it to refine its logic. Every defense from Heisenberg deepened the philosophical understanding of observation and measurement. It was as if the universe itself had chosen these two minds to wrestle its secrets into human language. Behind Einstein's determinism lay a profound emotional truth. He found comfort in necessity. To him, the idea that the future was open and uncertain was not freedom, it was loneliness. A deterministic universe, by contrast, was a universe in which nothing was lost, where every cause found its consequence and every action its echo. Even death, he once said, was meaningless in such a reality, for the distinction between past, present, and future is only a stubbornly persistent illusion. The same equation that described a planet's orbit described the trajectory of a soul through time. Nothing vanished, everything transformed. Determinism was not fatalism, it was immortality written in mathematics. Heisenberg, though younger, felt the opposite. To him, the openness of the universe was its greatest gift. In uncertainty, he found space for creativity, spontaneity, and discovery. A world perfectly predictable would be a world already finished, a cosmic machine running without surprise. The uncertainty principle made existence alive, like a melody that never repeats itself. But Einstein saw danger in this romanticism. He feared that by accepting indeterminacy, science would slide into subjectivism, that truth would dissolve into perception. For him, the purpose of physics was to transcend the observer, not to entangle with him. Reality, he said, must have properties independent of observation, or else it is not reality at all. He clung to that belief even as evidence accumulated against it, because to abandon it would be to abandon the idea that the universe could be truly known. The difference between their philosophies could be felt in their language. Heisenberg spoke of complementarity, probability, and interaction. Einstein spoke of symmetry, necessity, and elegance. Heisenberg's words were alive with movement, Einstein's were carved in stone, yet both were poets in their own right. Einstein once described himself as a deeply religious unbeliever, meaning that though he rejected the gods of men, he revered the order of the cosmos. Heisenberg, raised in the turmoil of a century breaking apart, found solace in the mystery that uncertainty allowed. For him, physics was not a cold machine but a conversation with nature, where the answers changed with the questions. The two men stood like twin pillars, one built of marble, the other of light, holding up the temple of modern science. As the decades passed, the world began to live inside the quantum realm. Technologies emerged that Einstein himself had helped inspire but could no longer philosophically accept. The photoelectric effect, which had earned him the Nobel Prize, became the foundation of quantum theory, yet its probabilistic interpretation remained foreign to his heart. He acknowledged its success, but not its completeness. He would smile politely when colleagues celebrated the triumph of uncertainty, then retreat into his study, where stacks of papers filled with tensor equations hinted at his continuing quest for unity. Heisenberg, meanwhile, carried the torch of quantum mechanics through war and peace, guiding a generation that saw in his principle not confusion but revelation. The world was learning to live with uncertainty, even as it built its machines upon it. There is a haunting symmetry in how their beliefs reflected the ages they lived through. Einstein's determinism belonged to the early 20th century, a time of faith in progress, logic, and universal law. Heisenberg's uncertainty belonged to the world after the Great War, a world fractured, fluid, unpredictable. Determinism was the dream of a world that believed in reason. Uncertainty was the truth of a world that had seen reason fail, yet both were attempts to find meaning in a cosmos that offered none freely. Einstein sought that meaning in necessity. Heisenberg found it in possibility. The battle between them was not only scientific, it was existential. Late in life, Einstein grew gentler toward the quantum world, though he never surrendered to it. He admitted that the theory worked, that its mathematics was exquisite, but he continued to insist that it was provisional. "I am convinced," he wrote, "that God does not play dice, but I also believe that he hides his plans." He accepted that human understanding might forever be incomplete, but he would not grant that reality itself was incomplete. He saw physics as an asymptotic journey, approaching truth infinitely, never reaching it, yet guided by faith that truth existed. Heisenberg, reading those words, felt both admiration and a quiet melancholy. He knew that Einstein's vision was too beautiful to be wrong, yet too rigid to be complete. Between their two visions lay the real universe, sometimes law, sometimes mystery, always more than either could grasp. When Einstein died in 1955, Heisenberg wrote that the world had lost not only a scientist, but a conscience. He described him as a man who believed that reason could touch eternity. In that tribute, one can hear both reverence and farewell, the acknowledgement that the age of classical faith had ended. Yet Einstein's determinism did not vanish. It continues to haunt the corridors of physics, reappearing in theories that seek to restore order to the quantum wilderness, hidden variable theories, pilot wave models, deterministic interpretations of the multiverse. Every attempt to reconcile quantum mechanics with relativity is, in some sense, an echo of Einstein's longing for unity. To understand his belief in determinism is to understand his humanity. It was not stubbornness that kept him from embracing uncertainty, it was love. Love for a universe that made sense, for a cosmos that could be trusted. He could not bear the idea of a reality that changed under observation, of a God who rolled dice. For Einstein, faith in determinism was faith in meaning itself. Without that, existence seemed arbitrary, and to him, arbitrariness was the only true blasphemy. Even when his peers moved on, he stayed at his desk, searching for the hidden law that would reconcile everything, the law that would prove that nature at its core does not gamble but sings in perfect harmony. Heisenberg's uncertainty principle may have won the argument of physics, but Einstein's determinism won the argument of spirit. It remains the heartbeat of every search for a theory of everything. Whenever a scientist seeks unification, whenever an equation aspires to describe the totality of existence, it is Einstein's voice that whispers, "The universe is not capricious." And perhaps he was right in a way even Heisenberg would not deny. For even within the probabilistic chaos of the quantum world, patterns emerge, symmetries repeat, constants remain faithful. The dice of God, if they are rolled, may still obey rules beyond human imagination. The second keynote, the belief in a deterministic universe, thus stands as Einstein's enduring monument. It is not a relic of outdated science, but a reminder of the human need for coherence. Determinism, in his hands, was never a denial of mystery. It was the conviction that mystery itself must have structure. His equation spoke of a cosmos that is not random but relational, where every event, however small, resonates through the whole. He saw the world not as a chaos of particles but as a symphony of necessity, where each note, once struck, reverberates forever. When we look back now, we see that Heisenberg and Einstein were not truly at war. They were two instruments, playing different parts of the same composition. Einstein wrote the melody of order. Heisenberg composed the harmony of uncertainty. Together they created the music of modern physics, a song that tells us the universe is both knowable and mysterious, both lawful and free. Determinism gave it rhythm, uncertainty gave it soul, and in that union, even if neither man could see it fully, lies the beauty of truth itself, that the cosmos is vast enough to contain both their dreams. In the humid summer of 1927, a young German physicist sat alone at his desk, surrounded by papers scrawled with equations that defied the very idea of certainty. Werner Heisenberg was only 26 years old, yet he had already begun to challenge centuries of scientific tradition. For months he had been wrestling with a paradox that refused to dissolve. When one tries to measure the exact position of an electron, its momentum becomes uncertain, and when one measures its momentum precisely, its position fades into ambiguity. The harder he tried to corner reality, the more it slipped through his fingers. What if, he thought, the problem wasn't in the measurements, but in the universe itself? That night, under a flickering lamp, Heisenberg's exhaustion gave way to insight. The world of atoms did not follow the logic of human expectation. It moved according to laws of probability, where certainty was an illusion born from our limited senses. Heisenberg's realization became immortal as the uncertainty principle, the idea that at the fundamental level, the very act of observation disturbs what is being observed. Nature, he concluded, did not possess definite properties independent of measurement. Instead, it existed in a state of potentiality, a realm of overlapping possibilities waiting to be collapsed into a single reality by the act of observation. It was an idea that would shake not only physics, but philosophy, theology, and even the way humanity understood truth itself. Heisenberg had opened the door to a universe that refused to be pinned down, a universe alive with ambiguity. The old dream of complete knowledge, of a cosmos behaving like a perfectly predictable clock, was gone. In its place stood a trembling truth, that at the heart of matter, uncertainty reigned supreme. The world Heisenberg discovered was not chaotic, it was paradoxical. On the one hand, his equations predicted experimental results with exquisite precision. On the other hand, they declared that such precision could never be total. The uncertainty principle was not a technical limit, it was a philosophical one. It told humanity that nature speaks in riddles, and every answer conceals another mystery. Heisenberg wrote, "What we observe is not nature itself, but nature exposed to our method of questioning." That sentence was a revolution. It meant that physics was not a window through which we observed reality, it was a mirror reflecting the interaction between the observer and the observed. Science had crossed a line into a new territory, where objectivity and subjectivity intertwined. For Einstein, this was blasphemy against the temple of reason, but for Heisenberg, it was revelation. He had not destroyed order, he had discovered a deeper one. The uncertainty principle was not a license for chaos, it was the geometry of the unknown. It defined the boundaries of what could be known, as surely as relativity had defined the limits of speed. Just as Einstein had shown that no object could move faster than light, Heisenberg showed that no measurement could penetrate beyond a certain precision. These limits were not defects, they were part of the fabric of reality. The young physicist understood the enormity of what he had uncovered. If position and momentum could not both be known, then cause and effect, so sacred to classical physics, became uncertain at the atomic scale. An electron might appear here or there, but the path connecting those points was not fixed. It was a spectrum of probabilities. To describe it, Heisenberg used mathematical matrices, grids of numbers that captured relationships between measurable quantities without assuming that those quantities had definite values. It was a new language for a new world, one that no longer depended on visual metaphors or mechanical analogies. The quantum world was not something you could picture, it was something you could only calculate. This abstraction horrified many older scientists. They had built their careers on the belief that nature was visualizable, that physics should describe a world that could be imagined. But Heisenberg, along with his mentor Niels Bohr, insisted that such imagery belonged to the past. The atom was not a miniature solar system, as classical physicists like to imagine. It was a cloud of potential existence, a wave of probability that only crystallized into form when measured. In this vision, reality itself became participatory. The observer was no longer a detached spectator, but a participant in the unfolding drama of existence. Heisenberg's insight reached far beyond the laboratory. It struck at the heart of human epistemology, the study of how we know what we know. If the observer changes the observed, then knowledge is never neutral. Every act of measurement carries bias. Every question shapes its answer. The implications rippled through philosophy, psychology, even art. The modernist painters of the early 20th century, experimenting with abstraction and multiple perspectives, were unknowingly echoing Heisenberg's physics. That truth has no single frame, that perspective defines perception. For Heisenberg, however, this revelation was not liberating, it was humbling. He did not rejoice in uncertainty, he respected it. He saw in it the boundary between human intellect and divine mystery. In lectures and essays, he warned against confusing uncertainty with ignorance. The uncertainty principle, he said, does not describe the imperfection of our instruments. It expresses the fundamental structure of the world. That structure was not chaotic, but balanced, an interplay of determinacy and indeterminacy, of knowable and unknowable. Heisenberg compared it to music. One can predict the pattern of harmony, but not the soul of the melody. The symphony of atoms played by rules, but its notes were born of probabilities. As word of Heisenberg's discovery spread, the physics community reacted with a mixture of awe and discomfort. Some embraced it as the final proof that classical determinism was dead. Others, like Einstein, saw it as an intellectual betrayal. But there was no denying its success. The uncertainty principle explained phenomena that had baffled scientists for decades: why electrons never crash into the nucleus, why spectral lines appear discrete, why atoms remain stable. In the realm of the very small, uncertainty was not the exception, it was the rule, and the more precisely physicists tried to observe that realm, the more the rule asserted itself. Nature, it seemed, guarded her secrets not with walls but with paradoxes. For Heisenberg, these paradoxes were not obstacles to truth, they were truth. He once said that the path to knowledge was like climbing a mountain shrouded in fog. As one ascends, the landscape becomes both clearer and more mysterious. The uncertainty principle was that fog, not to obscure reality but to reveal its contours. It forced humanity to confront a new kind of knowledge, one that did not claim absolute understanding, but sought harmony within limitation. In his conversations with Bohr, Heisenberg developed this philosophy further. Bohr introduced the idea of complementarity, that light and matter can behave as both particles and waves, but never both at once. These dual aspects are not contradictions but complements, different windows into the same underlying truth. Together, Bohr's complementarity and Heisenberg's uncertainty became the twin pillars of quantum mechanics, reshaping science into something less like a mirror of reality and more like a dialogue with it. The deeper Heisenberg explored his own theory, the more he realized how profound its implications were. It was not just that we could not measure everything. It was that nature itself might not possess definite properties until we ask about them. The universe, he proposed, is not a stage with actors moving independently. It is an unfolding script written in real time through observation. This idea redefined existence itself. Reality was not static. It was participatory, dynamic, relational. The observer and the observed were threads in the same cosmic fabric, woven together by the act of measurement. To many, this sounded like mysticism wrapped in mathematics. But Heisenberg's work was pure physics, tested and proven in experiment after experiment. When electrons passed through slits and formed interference patterns, when photons appeared to decide their path only when detected, the data spoke clearly. Uncertainty was not a flaw, it was fundamental. Every particle carried within it a wave of potential, a cloud of probability that described where it could be. Only when observed did that wave collapse into a specific outcome. Between the possible and the actual lay the entire mystery of creation. Einstein could never accept this. To him, reality must exist whether or not anyone observed it. But Heisenberg's mathematics refused such comfort. The act of measurement did not simply reveal reality, it created it, or at least selected one among countless possible realities. The notion was staggering. The universe, in its smallest details, was not a finished book but an open manuscript, written anew with each observation. Time and again, Heisenberg faced Einstein's challenges with quiet confidence. The old master would propose a thought experiment to disprove uncertainty. Heisenberg would show that the paradox vanished when one accounted for the disturbance caused by observation. The two men were playing chess with the universe itself, and neither could fully checkmate the other. The philosophical implications of Heisenberg's discovery soon transcended physics. Theologians found in it echoes of free will, the idea that even in a universe governed by laws, there is room for spontaneity. Philosophers saw in it the death of objective reality and the birth of relational truth. And artists, painters, poets, composers, found in it a license to embrace ambiguity. Modernism, existentialism, surrealism, all were in some distant sense cultural reflections of the quantum revolution. The certainties of the 19th century, God, reason, progress, had been replaced by probabilities, perceptions, and paradoxes. Yet, for Heisenberg, the uncertainty principle was never meant to destroy meaning. It was meant to remind humanity of its place within the cosmos. In a universe where even the smallest particle resists complete understanding, arrogance becomes impossible. Knowledge, he believed, must be tempered by wonder. In a lecture decades later, he said, "The first gulp from the glass of natural sciences will make you an atheist, but at the bottom of the glass, God is waiting." Those words captured the essence of his vision, science as humility before the divine complexity of creation. Heisenberg's discovery also changed the practice of physics itself. No longer could scientists pretend to stand outside their experiments. Every measurement became an interaction, a negotiation with nature. This realization paved the way for quantum field theory, for the study of entanglement, for the eventual understanding that even empty space seethes with virtual particles. Uncertainty was not a limitation, it was a window into deeper symmetries. The fabric of the cosmos, it turned out, was not solid but shimmering, vibrating, forever in flux. The uncertainty principle thus became more than an equation. It became a metaphor for existence. It taught that knowledge and mystery are not opposites but partners. The more precisely one understands one aspect of life, the more another aspect recedes into mystery. The human mind, like the quantum observer, cannot grasp the whole. It must choose its focus. Every act of knowing, whether in science or in love or in faith, is an act of narrowing possibilities into experience. Heisenberg's insight reached beyond atoms. It touched the human condition itself. By the time Heisenberg's uncertainty principle had taken root in the scientific world, the landscape of knowledge itself had shifted. What began as a mathematical insight had grown into a philosophical earthquake. The classical dream of total predictability had dissolved like mist before a rising sun, and in its place stood a new vision of reality, alive, participatory, uncertain. For Heisenberg, this was not a collapse of meaning, but its transformation. He had not broken the mirror of science. He had revealed that the mirror reflects both nature and the one who looks into it. Each observation was a dialogue between mind and matter, a moment when possibility became fact. The more he explored this revelation, the clearer it became that uncertainty was not confined to atoms. It was a principle of being itself. In the quantum world, particles did not possess properties independent of measurement, and time did not flow in neat sequences of cause and effect. Instead, events were linked through probabilities, interwoven patterns, where what could happen shaped what did happen. To understand the world meant to abandon the illusion of absolute separation. Observer and observed, subject and object, theory and reality, all were threads of a single cosmic fabric. In lectures across Europe, Heisenberg tried to communicate this new vision to students who still longed for the comforting solidity of the old world. He would draw diagrams not of particles, but of waves, fields of potential, rippling through space and time. Nature, he told them, is not composed of things, but of processes. Matter was no longer substance but interaction. The very concept of an object had to be reimagined. An electron was not a tiny ball of charge, it was a mathematical expression of possibilities, a probability wave that became tangible only when engaged. The universe was not a static architecture, but a dynamic conversation, and every act of measurement was a question posed to reality. This realization forced physicists to reconsider even their most basic assumptions. The notion that the world could be described independently of the observer no longer held. In the quantum realm, measurement did not merely record, it created. The observer became a participant in the unfolding of the universe, collapsing infinite possibilities into one concrete event. This participatory role of consciousness in physics would later inspire decades of debate, leading to ideas about the observer effect and the entanglement of mind and matter. Though Heisenberg himself avoided mystical language, his equations seemed to suggest that awareness itself might be woven into the structure of existence. Einstein resisted such implications with all the force of his intellect, yet even he could not deny the experimental power of quantum mechanics. Every test confirmed Heisenberg's prediction. When one variable was measured precisely, the other dissolved into uncertainty. The principle governed everything from the stability of atoms to the colors of stars. It was not merely a philosophical curiosity. It was the law of the microcosm. The universe had spoken, and it spoke in probabilities. For the first time, science was forced to admit that not everything that counts can be counted, and not everything that can be counted counts. To the philosophers of the age, this revelation was intoxicating. The rigid walls between science and metaphysics began to crumble. If reality depended on observation, then perhaps consciousness was not an accidental byproduct of matter, but a fundamental feature of it. Heisenberg himself, though cautious, acknowledged that the line between physics and philosophy had blurred. "We can never speak of reality without speaking of how we have observed it," he said. "The world is not given to us, it is chosen by us." This statement, radical in its humility, echoed ancient wisdom long forgotten, that knowledge is participation, not possession. Yet for Heisenberg, the uncertainty principle was not a declaration of chaos, it was the signature of harmony. He saw in it the balance between freedom and law, between chance and necessity. The electron was free to roam within the limits defined by its wave function, just as a note in music is free to resonate within the bounds of its key. Uncertainty gave nature its rhythm. Without it, atoms would collapse, stars would not shine, and life itself would be impossible. The same principle that denied perfect predictability also guaranteed stability. The universe, it seemed, had chosen ambiguity as the price of existence. As the world edged toward the chaos of another global war, Heisenberg's insights took on a haunting new relevance. The political storms of the 1930s mirrored the indeterminacy of the atomic world, nations teetering on probabilities, choices collapsing into fate. Heisenberg, caught within that maelstrom, continued to teach and write, clinging to the purity of physics as a refuge from ideology. Yet even in his solitude, the philosophical weight of his discovery deepened. The more he pondered uncertainty, the more he saw its reflection in human life. Just as particles exist only in probabilities, so too do human choices unfold among possibilities. Certainty, whether in science or morality, was a myth born of fear. Real understanding lay in embracing the flux. In the years that followed, as the atomic age dawned, the uncertainty principle found itself entangled in the very technologies that reshaped civilization. The transistor, the laser, the computer, all depended on the behavior of electrons moving in uncertain paths. The principle that once seemed a threat to knowledge had become its engine. Even Einstein's beloved determinism found new life within quantum equations, as physicists discovered that probabilities themselves obeyed deterministic laws of evolution. The paradox deepened. Uncertainty was predictable, randomness had pattern, and the boundary between chaos and order blurred into a continuum. Heisenberg often reflected on this irony with quiet amusement. In his later writings, he described the quantum world not as an abandonment of reason, but as its expansion. The old logic of certainty had been replaced by a new logic of complementarity, where opposites coexist and contradiction becomes harmony. A particle can be both wave and corpuscle, matter can arise from energy, and emptiness can seethe with virtual creation. This new worldview demanded not despair but imagination. The task of physics was no longer to conquer mystery, but to live with it creatively. Heisenberg's personal faith played a subtle role in his acceptance of uncertainty. Unlike many of his contemporaries, he did not see a conflict between science and spirituality. He believed that the limits of knowledge were not barriers but thresholds, places where the human mind touched the infinite. In private conversations, he would compare the uncertainty principle to the theological idea of divine hiddenness, the notion that ultimate reality reveals itself only partially, that mystery is not absence but presence veiled. His scientific humility mirrored a metaphysical one. The world, he thought, is intelligible enough to inspire inquiry, but mysterious enough to demand reverence. Einstein, reading these reflections, remained unconvinced. He admired Heisenberg's intellect but could not accept the philosophical surrender he saw in uncertainty. To him, physics must describe what is, not what might be. Yet even as he objected, he could not escape the gravitational pull of the new paradigm. The uncertainty principle had become indispensable to science, as foundational as the speed of light. And though Einstein fought it with reason, history sided with Heisenberg's insight. The experiments, the mathematics, the technologies, all confirmed it. Still, the tension between their worldviews endured, like two complementary truths refusing to annihilate each other. By mid-century, the philosophical implications of uncertainty had spread far beyond physics. Psychologists saw in it a metaphor for perception and behavior, that the act of observation changes what is observed, that certainty in human affairs is an illusion. Sociologists, artists, and poets all found resonance in the idea that meaning is relational, that reality is woven from context. In every field, Heisenberg's principle became a symbol of humility and creativity, the recognition that truth is not fixed but evolving. Heisenberg himself never claimed to have solved the mystery. In interviews near the end of his life, he spoke with a kind of serene acceptance. The more precise our knowledge becomes, he said, the more we realize how incomplete it must remain. His voice carried no despair, only wonder. He had spent his life navigating the boundary between the knowable and the unknowable, and he had found peace in the balance. Where Einstein saw imperfection, Heisenberg saw beauty. The uncertainty of the universe was its poetry, not its flaw. What began as a technical observation about the measurement of particles had become a revelation about the nature of reality itself. The uncertainty principle was not a retreat from truth. It was the recognition that truth is layered, multidimensional, relational. It invited humanity to replace arrogance with curiosity, rigidity with openness. In a sense, it restored innocence to science, the acknowledgement that the cosmos is still larger than the equations we use to describe it. As the 20th century unfolded into the 21st, Heisenberg's insight only grew more powerful. Quantum mechanics continued to reveal deeper mysteries, entanglement linking distant particles as if space itself were an illusion, quantum tunneling allowing matter to pass through barriers that should be impossible, virtual particles flickering in and out of existence within the vacuum of space. Every discovery reaffirmed uncertainty, not as ignorance, but as creativity, the cosmic improvisation at the heart of reality. The universe, it seemed, did not unfold like a script, but played like jazz, structured yet spontaneous, disciplined yet free. Heisenberg's principle thus became not just a law of physics, but a philosophy of existence. It taught that every act of knowing changes the known, that every truth is partial, that the quest for understanding is endless, and in that endlessness lies the dignity of science and the humility of humankind. The uncertainty principle does not mock knowledge, it ennobles it, reminding us that even the greatest minds stand before the infinite as learners, not masters. If Einstein's determinism was the heartbeat of reason, Heisenberg's uncertainty was its breath, the inhale and exhale of inquiry itself. Together they form the rhythm of modern thought. Certainty seeking, uncertainty answering, both essential, both eternal. The universe may never offer us final knowledge, but perhaps that is its greatest gift. For in uncertainty lies possibility, and in possibility lies creation. And so, as history looks back on the man who dared to proclaim that precision has limits, it sees not a destroyer of order, but a builder of depth. Heisenberg's uncertainty principle remains the compass of the quantum age, pointing not to the edges of ignorance, but to the horizons of wonder. It reminds us that the closer we come to understanding the nature of reality, the more deeply reality reminds us that we too are part of its mystery. At the Solvay Conference of 1927, the air was thick with cigarette smoke and debate, as if the room itself were vibrating with invisible particles of tension. It was there that Einstein and Heisenberg faced one another across a chasm not of personality but of philosophy. Around them sat the giants of the age, Bohr, Schrödinger, Planck, de Broglie, each trying to make sense of the strange new world that quantum theory had revealed. The discussions stretched late into the night. Equations covered the blackboards like hieroglyphs from another dimension. Einstein would pace, formulating questions with surgical precision, and Heisenberg would respond with quiet conviction, his voice calm but unshakable. These exchanges were not arguments in the ordinary sense. They were collisions of worldviews. To the audience, it was like watching two universes orbit one another, each illuminating the other's shadow. Einstein would begin with his famous thought experiments, asking what would happen if one tried to measure an electron's position and velocity at the same time. Surely, he argued, one could devise a clever apparatus to minimize disturbance. Heisenberg would smile slightly, explaining that the act of measurement itself changed the system. The photon used to see the electron would impart momentum, making perfect precision impossible. The limitation was not in the technology but in the nature of reality. Einstein shook his head. "God does not play dice," he muttered. Bohr leaned forward, his eyes gleaming. "Stop telling God what to do," he said. The room erupted in laughter, but beneath it lay an uneasy awe, for everyone present knew they were witnessing a moment when human thought was shifting its axis. These debates, though polite, carried the intensity of spiritual conflict. Einstein believed in a universe that existed independently of human consciousness, one governed by strict laws. Heisenberg, emboldened by the success of his uncertainty principle, argued that observation was part of the fabric of those laws. The universe, he insisted, does not reveal itself fully. It responds. For days the discussions continued. Einstein's logical traps grew ever more intricate, Bohr and Heisenberg's defenses more profound. Each argument ended not in resolution but in revelation, as though truth itself hovered just beyond reach. Observers recalled that even in disagreement, their respect for one another was immense. Einstein would grin, admitting that the young men were clever. Heisenberg would bow his head slightly, acknowledging that no one could reason like Einstein. It was an intellectual duel fought with elegance and precision, a testament to the beauty of science as dialogue rather than dogma. As the conference closed, no one could declare victory. Einstein remained unconvinced by the probabilistic view of nature, and Heisenberg remained unmoved by Einstein's appeal to hidden determinism. Yet something profound had occurred. The debates at Solvay crystallized the divide between classical and quantum visions of reality. They showed that science was not a monolith but a living conversation, shaped as much by imagination as by evidence. The clash of reason and probability was not a war to be won but a dance to be understood. Einstein's insistence on order and Heisenberg's acceptance of uncertainty became complementary forces driving physics forward. The Solvay encounters entered legend, not because they settled the question but because they revealed that the question itself was the heart of human inquiry. In the years that followed, those who had witnessed the debates would speak of them in reverent tones. They remembered Einstein's quiet confidence, Heisenberg's clarity, Bohr's philosophical patience. They remembered how, amid the chalk dust and arguments, the boundaries of reality seemed to blur. What emerged from that smoke-filled room was not just a theory of particles, but a new understanding of knowledge itself, that truth may wear many faces, and that even in contradiction, the pursuit of it unites rather than divides. The divide between Heisenberg and Einstein was not only scientific, it was deeply philosophical, a clash between two visions of existence itself. Einstein stood for objective reality, a world that existed independent of human perception. He believed that the moon was there even if no one looked at it, that truth had an existence outside consciousness. Heisenberg, on the other hand, began to see that the universe might be far more subtle, that what we call reality could depend on the very act of observing it. The question that haunted their generation was simple yet shattering. Does reality exist on its own, or do we, through observation and measurement, bring it into being. This was not merely a scientific puzzle, but a philosophical revolution that reached into the foundations of human thought. Einstein's realism had grown out of centuries of scientific progress. From Galileo to Newton, humanity had learned to trust that the universe followed laws independent of us. Whether anyone measured them or not, the planets moved in predictable orbits, apples fell with consistent force, and light traveled through space according to immutable rules. Einstein's own theories of relativity had deepened that trust. To him, the beauty of science was its objectivity. The job of the scientist was to uncover the blueprint that already existed in nature, not to influence or alter it. For him, the observer was a passive witness to a grand cosmic design that existed long before humankind could comprehend it. Heisenberg shattered that comfort. His mathematics implied that the observer could not be separated from the observed. The more closely one looked, the more the act of looking altered the outcome. At the subatomic level, reality seemed to exist not as fixed entities, but as possibilities, waves of potential that only solidified into facts when observed. This was not imagination. It was verified by experiments that defied all classical logic. The photon that passed through two slits could behave like a wave or a particle, depending on how it was measured. Reality was not something waiting to be discovered. It was something participating in its own creation. To Heisenberg, this was not subjectivism but honesty. Science, he said, must now include the human observer within its equations, for the universe was not external to consciousness, but entangled with it. Einstein resisted this idea with all the strength of his intellect. To him, the suggestion that observation defined reality was a betrayal of reason. He feared that if reality depended on the observer, science would lose its foundation in truth. "Do you really believe," he asked Heisenberg, "that the moon is not there if you are not looking at it?" It was more than sarcasm. It was the voice of a man defending the dignity of existence itself. But Heisenberg was unmoved. The moon, he said, was not the same as an electron. At the quantum scale, the rules of intuition no longer applied. Reality, there was not a solid structure but a dynamic relationship between what is measured and the means of measuring it. Heisenberg did not claim that reality was unreal, only that its nature was participatory. This divide revealed two archetypes of thought. Einstein's realism represented faith in the independence of the cosmos, a universe that existed with or without witnesses. Heisenberg's relational view represented a new humility, acknowledging that we are woven into the very tapestry we study. Einstein saw this as surrender. Heisenberg saw it as evolution. In a sense, they were both right. The macroscopic world of stars and planets obeyed Einstein's objectivity, while the microscopic realm of electrons and quarks obeyed Heisenberg's uncertainty. The two domains were not enemies, but reflections of different scales of truth, yet neither man could accept the other's compromise, for to do so would be to redefine reality itself. Philosophers and theologians soon joined the debate. Some compared Heisenberg's universe to ancient Eastern thought, where observer and observed are inseparable. Others warned that it threatened the very meaning of objectivity. But beyond the controversy, a deeper insight began to emerge. Perhaps the universe was not divided between subject and object, mind and matter, but was instead a single indivisible whole, expressing itself through interaction. Heisenberg's mathematics hinted at this unity long before it could be visualized. The quantum world was relational not because it was mystical, but because everything within it was connected. For Einstein, this idea was intolerable. His realism demanded that things exist in definite states regardless of measurement. He could not imagine a cosmos built from probabilities that depended on consciousness to solidify into form. To him, the job of science was to find the hidden variables that would restore certainty, to reveal the reality beneath the appearances. But Heisenberg believed that Einstein was chasing a ghost. The uncertainty was not in the instruments or the equations. It was in the nature of being. The quantum realm did not hide reality. It was reality, seen through a new lens that refused to separate the seer from the seen. The philosophical implications were staggering. If Heisenberg was right, then knowledge could never again be detached from the knower. The human mind was no longer a spectator. It was a participant in creation. This did not mean that reality was subjective, but that it was relational. Existence was not a static thing but a web of interactions, constantly renewed through observation and exchange. Every measurement, every perception, every thought became part of the unfolding story of the universe. The act of knowing had become a creative act. In the quiet years after their great debates, both men continued to wrestle with this idea. Einstein sought solace in equations that described an independent cosmos, while Heisenberg found wonder in a universe that could not be pinned down. Between them stretched a question that has never been fully answered. Does reality exist on its own, or do we bring it forth by looking? It was a question too vast for proof, yet too essential to ignore. The dialogue between objectivity and observation still defines science today, echoing through every experiment, every theory, every act of curiosity. In the end, the clash between objective reality and observer-dependent reality was not a conflict to be solved, but a balance to be lived. Einstein gave us the confidence that truth exists. Heisenberg gave us the humility to know that we shape it. Together they revealed that the universe is both independent and intimate, both external and shared. The moon is there, yes, but when we look at it, something of ourselves is reflected in its light. Behind the thunder of equations and the glare of philosophical conflict, there was something tender and profoundly human about the relationship between Heisenberg and Einstein. They were not enemies, they were mirrors, each reflecting the other's deepest convictions, each forcing the other to look inward. Beneath their public disagreements lay respect, even affection, woven with frustration and wonder. Einstein, the elder sage with hair like wild light, saw in Heisenberg a brilliance that both inspired and unsettled him. Heisenberg, the young revolutionary, saw in Einstein a figure of almost divine intellect, a man whose every sentence carried the gravity of the cosmos. Their debates were not merely about particles and probabilities. They were a dialogue between generations, between certainty and surrender, between faith in order and acceptance of mystery. When Heisenberg first met Einstein in Berlin, he expected to meet a stern critic, but instead found a gentle mentor. Einstein listened intently, questioning carefully, challenging assumptions without cruelty. Heisenberg described him as a man who saw through you without judgment. Yet as quantum mechanics began to rewrite the laws of nature, that warmth was tempered by tension. Einstein could not accept that the young man's equations left no room for absolute truth. Heisenberg's uncertainty principle, elegant though it was, seemed to him a confession of defeat. For Einstein, science was supposed to bring clarity, not blur the lines of existence. But Heisenberg admired his refusal to yield. He saw in Einstein's determination a moral strength that science itself required, the belief that reality, however complex, must ultimately make sense. Their conversations often drifted beyond mathematics into the realm of philosophy, even theology. They spoke of beauty, of the divine, of the strange symmetry that seemed to govern both music and matter. Einstein would play his violin in the evenings, coaxing melodies that seemed to echo the order he sought in the universe. Heisenberg, a pianist, once joined him, and for a few hours the two men who could not agree about reality found harmony in sound. In those moments the arguments vanished. The music carried them to a place beyond logic, where the patterns of physics became emotion. Later, Heisenberg would recall that evening as the moment he truly understood Einstein, not as an opponent, but as a man seeking connection between mind and meaning. The respect between them was tested, but never broken. Even when Einstein publicly rejected the probabilistic nature of quantum mechanics, he did so with a tone of lament, not scorn. Heisenberg, though wounded by the criticism, never retaliated. He wrote that Einstein's doubts came from the same place as his greatness, a refusal to accept a world without coherence. Their letters, exchanged over the years, reveal warmth beneath the arguments. Einstein would write, "You are too young to understand how deeply I wish your theory were wrong." Heisenberg replied, "I am too young to wish you were right." Behind those words was a love for truth so strong that disagreement became its purest expression. As the decades passed and the world darkened with war, their paths diverged, but their connection endured. Einstein fled to America, his heart heavy with exile, while Heisenberg remained in Germany, caught between duty and conscience. Each carried the weight of history in different ways, yet even as political lines divided nations, the thread of intellectual respect between them never snapped. When Einstein heard that Heisenberg was struggling under political scrutiny, he spoke kindly of him, defending his integrity though they still disagreed about the cosmos. Heisenberg, in turn, continued to refer to Einstein with reverence, calling him the conscience of science. Their differences were, in truth, complementary expressions of the same longing to understand the ultimate order of existence. Einstein sought it through determinism, through a universe of laws written before time. Heisenberg sought it through humility, through acceptance that mystery was not ignorance, but the very texture of being. Where Einstein demanded logic, Heisenberg listened for resonance. Together they embodied the dual nature of human inquiry, the will to know and the grace to wonder. Neither man could yield because neither wanted to betray the truth he saw. Yet both knew that their struggle enriched science itself. Their debates forced physics to stretch beyond its limits, to embrace both clarity and ambiguity, both precision and awe. In private moments, Heisenberg admitted that he felt gratitude for Einstein's resistance. Without his challenge, he said, quantum theory would have become arrogant. Einstein's skepticism acted as a compass, reminding the young physicists that every discovery must still answer to reason, and Einstein, for all his frustration, never dismissed Heisenberg's genius. He said once that if the uncertainty principle were wrong, the young man will have made the most beautiful mistake in physics. That word, beautiful, was not flattery, it was recognition. For Einstein, even disagreement could be art when pursued in good faith. The legacy of their mutual respect became a model for how science evolves, not through victory, but through dialogue. Their intellectual conflict proved that truth is not found by silencing opposing voices, but by letting them refine one another. In the end, their friendship was like quantum superposition, two states existing at once, tension and tenderness, opposition and admiration. They never reconciled their views, yet neither could exist fully without the other. Einstein's realism gave weight to Heisenberg's abstraction. Heisenberg's uncertainty gave depth to Einstein's order. Together, they created the most fruitful argument in the history of science. When Einstein passed away in 1955, Heisenberg felt the loss not only of a rival but of a kindred spirit. He wrote, "A light has gone out, but its warmth remains." That warmth was the bond of two seekers who, though they looked at the same universe from opposite sides, shared the same devotion to understanding. Their relationship was proof that intellect, when guided by humility, becomes a bridge rather than a wall. They taught the world that science at its highest level is not competition, it is communion. And even now, when physicists speak of uncertainty or relativity, they echo not just theories, but the echo of a friendship built on wonder, courage, and respect. The legacy of the clash between Heisenberg and Einstein did not end with their lives. It became the heartbeat of modern physics and the philosophical foundation of the 21st century. The debate between determinism and uncertainty, between objectivity and participation, gave birth to the world we now inhabit, a world of quantum technology, relativity-guided cosmology, and philosophical humility before the unknown. Their conflict shaped the way humanity asks questions about nature, not only in laboratories, but in the quiet corridors of thought, where scientists and philosophers still seek the meaning of reality. Every discovery made since then has carried the echo of their voices, one demanding order, the other embracing mystery, both forever intertwined. After the dust of their debates settled, the world realized that the argument itself was more important than its outcome. Einstein had defended the idea that reality is absolute and coherent. Heisenberg had revealed that perception is an inseparable part of it. Together, they taught that knowledge advances not through certainty, but through the dialogue between opposites. Their tension became the engine of progress. From that fertile conflict emerged quantum electrodynamics, particle physics, quantum computing, and even the modern search for a theory of everything. Each of these revolutions owes its existence to the balance they struck, the need to describe a universe both lawful and elusive. In time, Einstein's dream of unity and Heisenberg's principle of limitation began to merge in unexpected ways. The quantum field theories that followed showed that uncertainty itself obeys strict mathematical rules, as if the dice God throws fall according to hidden harmonies. Physicists like Feynman, Dirac, and later Hawking stood on the shoulders of both men, blending Einstein's demand for beauty with Heisenberg's acceptance of ambiguity. The universe revealed itself not as a contradiction, but as a symphony in which determinism and probability are different notes of the same chord. Reality, it turned out, was not a battlefield between their ideas, but a landscape shaped by both. Beyond science, their struggle reshaped the human understanding of existence. Philosophers began to speak of relativity and uncertainty as metaphors for life itself. Artists found in quantum theory a reflection of modern consciousness, fragmented, participatory, subjective yet structured. The old notion of truth as a fixed monolith gave way to a vision of truth as relational, contextual, and evolving. Even in theology, echoes of their debate appeared. The recognition that the divine may reveal itself through law and through mystery, through the predictable and the unforeseen. Einstein's God of order and Heisenberg's God of wonder became two faces of the same infinity. Their legacy also transformed the moral character of science. Both men lived through an era when knowledge had begun to unleash forces of terrible power. The atomic bomb was born from the equations they inspired, and yet both warned against using discovery without wisdom. Einstein's pacifism and Heisenberg's reflections on responsibility became a moral compass for generations of physicists who realized that understanding the universe also meant bearing the burden of its consequences. Their intellectual duel had started as a question of what reality is, but it ended as a lesson in what humanity must become: curious yet humble, powerful yet ethical. In modern physics, experiments in quantum entanglement, teleportation, and computing continue to revisit the very questions Einstein and Heisenberg raised. Each new discovery seems to vindicate both. The precision of relativity and the unpredictability of quantum mechanics coexist in the same equations. Space and time bend as Einstein predicted, but at the smallest scales, uncertainty reigns as Heisenberg described. Scientists now accept that reality is layered, that its nature changes with scale, and that no single viewpoint can capture the whole. What once seemed a contradiction is now seen as complementarity, a harmony born of difference. Their influence reaches even into daily life. Every smartphone, every laser, every MRI scanner carries within it the mathematics of uncertainty. Every GPS signal corrects itself through relativity. The technologies that define modern civilization are living proof that both men were right in ways they could not have imagined. The argument that once divided them now powers the global age of information, energy, and communication. The universe, as they each foresaw from different directions, is both mysterious and knowable, both elusive and intimate. But perhaps their greatest legacy lies in what they taught the human spirit. They showed that truth is not a possession but a pursuit, that science is not about victory but about vision. Einstein's unwavering belief in order gave us courage to seek unity in chaos. Heisenberg's acceptance of uncertainty taught us to find beauty in limitation. Their dialogue continues not in conference halls but in every human mind that looks at the stars and wonders how far understanding can go before dissolving into awe. The battle for the nature of reality became, in the end, a parable of humanity itself, forever reaching, forever questioning, never fully certain, yet never without faith that meaning waits beyond the unknown. So when we speak today of quantum physics or relativity, of probability or causality, we are speaking in the language they forged through disagreement. The tension between their ideas still fuels every step toward discovery. Einstein gave the world its foundation, Heisenberg gave it its frontier. Between them lies the bridge that connects certainty with curiosity, reason with imagination, and knowledge with humility. Their legacy endures because they did not merely change what we know, they changed how we know, and in doing so, they made the search for truth a living, breathing act of wonder that will never end.